So I showed you how we rewrite the query likelihood retrieval function into a form that looks like the formula on this slide after we make the assumption about smoothing the language model based on the collection language model. Now, if you look at this rewriting, it actually would give us two benefits. The first benefit is it helps us better understand this ranking function. In particular, we're going to show that from this formula, we can see smoothing with the collection language model would give us something like a TF-IDF weighting and length normalization. The second benefit is that it also allows us to compute the query likelihood more efficiently. In particular, we see that the main part of the formula is a sum over the matched query terms. So this is much better than if we take a sum over all the words. After we smooth the document language model, we essentially have non-zero probabilities for all the words. So this new form of the formula is much easier to score or to compute. It's also interesting to note that the last term here is actually independent of the document. Since our goal is to rank the documents for the same query, we can ignore this term for ranking because it's going to be the same for all the documents. Ignoring it wouldn't affect the order of the documents. Inside the sum, we also see that each matched query term would contribute a weight. And this weight actually is very interesting because it looks like a TF-IDF weighting. First, we can already see it has a frequency of the word in the query, just like in the vector space model. When we take a dot product, we see the word frequency in the query to show up in such a sum. And so naturally, this part would correspond to the vector element from the document vector. And here indeed, we can see it actually encodes a weight that has similar effect to TF-IDF weighting. Now I let you examine it. Can you see it? Can you see which part is capturing TF and which part is capturing IDF weighting? So if you want, you can pause the video to think more about it. So have you noticed that this P sub sin is related to the term frequency, in the sense that if a word occurs very frequently in the document, then the estimated probability here would tend to be larger. So this means this term is really doing something like a TF weighting. Now, have you also noticed that this term in the denominator is actually achieving the effect of IDF? Why? Because this is the popularity of the term in the collection. But it's in the denominator. So if the probability in the collection is larger, then the weight is actually smaller. And this means a popular term will actually have a smaller weight. And this is precisely what IDF weighting is doing. Only that we now have a different form of TF and IDF. Remember, IDF has a logarithm of document frequency. But here we have something different. But intuitively, it achieves a similar effect. Interestingly, we also have something related to the length normalization. Again, can you see which factor is related to the document length in this formula? Well, I just said that this term is related to IDF weighting, this collection probability. But it turns out that this term here is actually related to document length normalization. In particular, alpha sub d might be related to document length. Right? So it encodes how much probability mass we want to give to unseen words. How much smoothing do we want to do? Intuitively, if a document is long, then we need to do less smoothing because we can assume the data is large enough. We probably have observed all the words that the author could have written. But if the document is short, then alpha sub d could be expected to be large. We need to do more smoothing. It's like that there are words that have not been written yet by the author. So this term appears to penalize long document in that the alpha sub d would tend to be larger than for a long document. But note that the alpha sub d also occurs here. And so this may not actually be necessarily penalizing long documents. The effect is not so clear here. But as we will see later, when we consider some specific smoothing methods, it turns out that they do penalize long documents, just like in TF-IDF weighting and the document length normalization formulas in the vector space model. So that's a very interesting observation, because it means we don't even have to think about the specific way of doing smoothing. We just need to assume that if we smooth with this collection language model, then we would have a formula that looks like a TF-IDF weighting and document length normalization. What's also interesting that we have a very fixed form of the ranking function. And see, we have not heuristically put a logarithm here. In fact, if you can think about why we will have a logarithm here, if you look at the assumptions that we have made, it will be clear it's because we have used a logarithm of query likelihood for scoring. And we turned the product into a sum of logarithm of probability, and that's why we have this logarithm. Note that if we only want to heuristically implement the TF weighting and IDF weighting, we don't necessarily have to have a logarithm here. Imagine if we drop this logarithm, we would still have TF and IDF weighting. But what's nice with probabilistic modeling is that we are automatically given a logarithm function here. And that's basically a fixed form of the formula that we did not really have to heuristically design. And in this case, if you try to drop this logarithm, the model probably won't work as well as if you keep logarithm. So a nice property of probabilistic modeling is that by following some assumptions and the probability rules, we'll get a formula automatically. And the formula would have a particular form, like in this case. And if we heuristically design the formula, we may not necessarily end up having such a specific form. So to summarize, we'll talk about the need for smoothing a document language model. Otherwise, it would give a zero probability for unseen words in the document. And that's not good for scoring a query with such an unseen word. And it's also necessary in general to improve the accuracy of estimating the model representing the topic of this document. The general idea of smoothing in retrieval is to use the collection language model to give us some clue about which unseen words should have a higher probability. That is, the probability of an unseen word is assumed to be proportional to its probability in the collection. With this assumption, we've shown that we can derive a general ranking formula for query likelihood that has the effect of TF-IDF weighting and document length normalization. We also see that through some rewriting, the scoring of such a ranking function is primarily based on sum of weights on matched query terms, just like in the vector space model. But the actual ranking function is given us automatically by the probability rules and the assumptions that we have made, unlike in the vector space model, where we have to heuristically think about the form of the function. However, we still need to address the question how exactly we should smooth a document language model, how exactly we should use the reference language model based on the collection to adjust the probability of the maximum likelihood estimator. And this is the topic of the next lecture.